Good evening. Welcome to an evening of machine learning. You might do okay too. Organised by MIIA and AIMS. The MIIA part was organised by Jacques, whom you'll meet in a second if you don't know him already. He's the one responsible for the photography.
It's me.
The AIMS part was organised by Ludik, whom if you haven't met, you won't tonight. His baby arrived 2 weeks early. So he's at home on duty. And he's with us in spirit, but I'm afraid he can't just benefit from all the work he did with Jacques in organising tonight. Where are you? You're at AIMS, South Africa. AIMS is a Pan-African organisation for training quantitative students with quantitative skills, mathematics, physics, computing, statistics, and so on. This is Pan-African. This is the first of 6 centres throughout the continent. And the students who come here have 4 years quantitative training and then do a 1-year structured master's coursework with a 3-month research project, after which they tend to go on and do a research MSc or join industry or government. Many of them do PhDs and become academics too. But we're especially interested in the hybrid between academia and commerce and industry and business. And it's that hybrid which we see as the new generation of academics, which we're especially pushing from Africa, and we hope it will have an impact. So, this is AIMS South Africa, which has been going for a little bit less than 15 years. It was started by a physicist, Prof, whose family was here, but the family was forced away overseas in the apartment years. I'm not South African, so I'm staying away from things politically. But he took the chance to pay back Africa with this Pan-African organisation, and we hope it will go strong, go from strength to strength. Welcome to AIMS South Africa. Now, to start the program, it's a great pleasure to introduce Professor Grindrod from, what's it called again? Oh yeah, Oxford University. That's in the UK. Apparently. Pete's had the model career in terms of the academic hybrid that I just mentioned between commerce and academia. He's oscillated between the two all his adult academic life. Yes, that's right. So he's a model for our students, but also I think for the next generation. I'm going to leave him, I think, to speak for himself, which is what he does best. Please join me in welcoming Pete.
Thanks very much, Jeff. I'm going to kick this off by showing you a movie that one of my industrial partners, this is how they present maths in their domain. Let's have a look at this. Okay, so that's a fairly radical and sort of slightly embarrassing way that non-mathematicians would make a business using mathematics which is distinctive for them and differentiating in their business sense, if not a mathematical sense, What's going on here? Well, we're seeing more and more companies that exist on digital platforms, and so I think of them as customer-facing companies. But even old-fashioned customer-facing companies are going to change. So in the UK now, the major banks are all closing their outlets, their branches, and things like that, because everybody's banking online. They don't really need lots of branches anywhere, so they can pull that cost out and save that money and give that money back to customers in different ways. We're seeing Amazon become not just a bookseller, but a seller of anything. Particularly now they're a seller of Amazon Web Services, and so they're creating whole new services through their ability to leverage their digital presence and their brand. There isn't really a customer-facing sector that's going to remain untouched in all of this. And so we've seen both the economy and a certain amount of society through prosumer stuff, like blog pages or TripAdvisor or things like that, or through peer-to-peer stuff like Twitter, like WhatsApp, those sorts of applications becoming actually a way of life. And so even large traditional companies, one of the companies I work with is Emirates Airlines, actually we're having to rethink what it will mean to be an airline servicing the customer in terms of leisure, travel and whatever else they need, rather than just being a sort of traditional airline that basically sells you a ticket, puts you on a plane and you get to your destination. What happens when companies become data rich? So think about companies that didn't used to have a lot of data, but now they do. They pivot, they flip from being supply-centered to being customer-centered. And this is a big change for them, and over the last 20 years we've seen this change whole sectors. So supermarkets used to worry about their supply chain, now they have loyalty cards and basket data and e-presence, and they worry about why people ever buy anything, and they're customer-centered. We've seen the same with mobile phones. So the value of voice and text is going through the floor, so the phone has to be a marketplace, it has to be a bank, we could have education, we could have health advice, all sorts of things like that. And they have to worry where their shareholder value comes from, because they've sold us all 1.5 phones, they can't really sell any more, and so they have to get closer to the customer. And being closer to the customer in all these sectors is going to mean understanding customer data and getting value out of data. Now, for we mathematicians, that presents a little problem, because not all of this data is available to us when we're working in public spaces. So, for example, when sort of big data and analytics first got going, we saw a lot of work inside academia. So I'm thinking about the late 90s and early 2000s. There's a huge amount of work working in the sort of the biosciences. So genome, proteome, metabolome, and then through to unstructured data, videos of mice and all sorts of things. So a huge collection of data. And there was this idea at the time that there would be huge databases with all the necessary stuff in, and these needed to be web-enabled so that researchers from all over the world could come and hit this data with their marvelous algorithms and so on. It was called bioinformatics, and it was a very costly event in the early first 5 years of this century. But at the same time of that, some of us were in industry, and we used to think, well, that isn't big data at all. Come to Walmart's headquarters, and we'll show you big data. They were just miles away. And they also had another luxury, which you don't find too often in commercial things, is that, if you really had the proteome of your organism, you can work on that for as long as you like until you get the right answers. But we've got a problem here. When we're doing stuff real time during the X Factor or Game of Thrones, then we've really got to do it like now or near to real time, and that very much limits the sort of algorithms that we would want to do. So I've been given a course here this week really looking at analytics for customer-centered data resources, where I'm thinking really of businesses which are pulling in data from customer transactions or customer events on a daily, hourly minutely, secondly kind of basis. And that very much colours the sorts of things that we can accept. There's another differentiation between data. Some data is nice and clean, and for mathematicians it's in orderly tables, so we've got a vector as a point and all this sort of thing. Lovely structured data, that's what we love. Actually, what we tend to get from industry most of the time are things like unstructured data, so videos, images, all sorts of things that have to be interpreted first. And that itself requires a level of learning, often machine learning, in order to interpret those things. And I'm sure others are going to talk about this, but I mean, we have an issue there in that we like to sort of take these unstructured objects and pull some structured data out of them and kind of map them to them. And so an example I was looking at recently where we created a little bit of machine learning app that could look at any photograph with an aeroplane in it, and it would have a good guess as to what the make of the plane was and who owned it. So what the tail was, whether it was an Emirates plane or KLM plane, South African Airlines plane, and what sort of plane it was. Sometimes it would come up to say military plane, or whatever. And of course, then we categorise things. So we've moved unstructured information towards a more structured information that we can use later. There's a big problem with proprietary data because very often the companies don't know what they don't know, and so their first resort is to keep all their data locked up and not allow it out of the house, just in case there's something high value or lethal in it. And by giving it away or creating a public version of the data, there might be a severe risk. For example, maybe some analyst in the newspaper could write an article and say, look, they're not being very good, and blah, 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 and it would affect their share price. So there are real reasons why companies, it's not just that they don't want to let mathematicians in public spaces have it. There are real reasons, risk reasons, why they don't want to allow data to leave their premises or leave their environments. And that does create a problem for us because we have to find a way to work with those companies. And obviously some of the results, like the data, are going to remain proprietary. But I mean, you can't lock up a method. And the methods, I always think, must be open and publishable and open to inspection by other scientists. And that's kind of their guarantee. So even if you have proprietary data and you're a company, let's look at 3 big reasons why you should come and mess about with mathematicians in open spaces. The first reason is that companies are going to find it increasingly difficult to hire mathematicians. Anybody with mathematical skills that wants to move towards data science, actually, there's a world shortage, a global shortage of these things. And we're already struggling in the UK to fill up vacancies in companies and vacancies in universities for people who have some or all of those skills. The second thing is that while they're running their company and doing all this lovely stuff in the digital advertising industry, science isn't sleeping, is it? Actually, every day, every month, people are writing smart papers, looking at new algorithms, looking at new things to say, and I'm going to talk a little bit about the newness later on in this talk. But the fact is that there's a whole sort of conveyor belt of fresh ideas that may be better or may be differentiating for companies. And so companies need to connect with that. So they need the people and they need ideas. And in actual fact, they need people to think outside of their own boxes. Because they're all in a company and they all see things a certain way. They've got this kind of group think. And they need people like us to come out who are much more generalists to think about other things that might be happening across the wacky world of science that we might be able to bring to them. Very often, of course, we'll already have some, let's call it platform, but it's really just codes or ideas that we've used before and things like that. But actually, for a company, you've got to develop all of that. And you can waste a lot of money there because it's all at risk. So coming in and working alongside people who already have got a track record and know what they're doing actually saves a lot of money because we can start Monday. So whether you're coming at it from an academic group, research group, or whether you're coming at it from wanting to start up your own company and consulting to larger companies, actually there are lots of very good reasons why companies will give you airtime and talk to you. And then you have to make an arrangement so that you can do work on their proprietary data, which is beneficial to them. But actually make it very clear this has to be a two-way street. There must be benefits to us. And what benefits do we want? Well, we want challenges. All mathematicians, So data scientists are no different. We love challenges. Secondly, we want to feel as though the data will probe us or challenge us in ways that maybe we haven't been challenged before, and so then we'll invent new mathematics and be able to think about and then write up and publish new ideas that are going to get us over these things. So it really is a sort of two-way street, and there ought to be a two-way dividend. Insight. Let's have a think about insight. So, distillation, that's a lovely word, isn't it? Distillation. Let's just think about that. So what we're doing, we're taking a huge amount of data and we want to distill a very, very keen amount of insight from that. Most of the data we see isn't going to be useful for us, but some of it is going to lead to key insights and what I call actionable insights. So it's no good really just showing people visualizations of data, because the first time they see it, they'll go, yeah, wow. And the 100th time they see it, they don't really want to see it. You've got to actually lead them to where the insight is. And you've probably all sat through talks where somebody took a kilogram of data and converted it into a kilogram of power. Here's another example. Here's another example. Actually, it's much better if you test yourself and you say, well, what is this slide really showing that I didn't already know from the last slide? You know, I don't really need to add weight. I don't need examples for doing that. Actually, there should be some insight and it should be actionable. So you need to ask the question, as a result of knowing this, you can X, Y, Z. And of course, that makes us slightly uncomfortable as scientists because we don't really know the business end of things. We just know the mathematical end of things. But nevertheless, that's the goal. We want to produce insight that's valuable, and then the company will say, well, that gives us a competitive edge against our competitors. So Bloom believe that the mathematics that they do with these social networks, these peer-to-peer communications networks, and things like that, give them a competitive edge over other digital marketing organisations, and the evidence of their customer base says that's the case, at least for now. So they're all working and we're all working to help them to continue that so that they stay in the lead, because they've got many competitors that would like to catch them up. Analytics. Analytics is changing. And broadly we have sort of a number of methods which are now reaching some maturity in terms of scale. So there are some methods, and machine learning and deep learning are good examples where they've always been data hungry and they've always needed large amounts of data to run them. But there are other methods, and an example is persistent homology. I'll explain that in a moment, but computational topology, where actually having a lot of data wouldn't help because the algorithms weren't very efficient. So if we've got data points in a data cloud, if n is 10,000, we're just about okay. If n is 100 million, we can pack up and go home because this is never going to come back, this calculation. And so there's quite an urgency in creating new kind of algorithms which will work faster, maybe through fancy ways of doing things or fancy ways of sampling and resampling, hierarchical ways of sampling. Indeed, so the multi-level Monte Carlo is the thing I always think of there, because that's a great example of multi-level sampling. But actually the same ought to be possible in terms of something like persistent homology. Let me explain what that is. So the idea is you've got data points. So imagine a cloud of points, and imagine that you blow up a balloon at every point. This is called filtration. So the radius of the balloons are all the same, they're all uniform. Silent, that radius. When the balloons are very small, I've just got little balloons around every point, so I've gained nothing. As they start to get bigger, the balloons sort of join up, and I get shapes. I get shapes with holes in, and then eventually the balloons get too big, so the holes get filled up. But the holes persist for a while, and holes are represented by homologies in an algebraic sense. And so we have persistent homologies, but these features persist for a range of these different filtration things, and they appear at one point and disappear at other. Obviously, if you've got things that hardly persist at all, that's just noise. But structure, shape of data, is the holy grail. So this would be like a sort of Fourier transform. It's a multi-level kind of multi-resolution analysis, just as the Fourier transform is. But instead of splitting things up into sine waves, we're splitting things up into algebraic characteristics of the whole. And the idea is that that would give us a real good way of comparing different types of data cloud, one from another. So if it was the data cloud of all the activity on the internet in the United Kingdom, we could easily compare today with yesterday and then see if anything really rather shocking started to happen and things like this. So that's an example where things are coming out of the science, and that's not new. I mean, that's sort of 10 years old, really. But it hasn't really got to the point where we can use it on anger on very large sets. So we're having a good old think about that across a number of disciplines at Oxford, and that involves maths, computer science, and some applied mathematicians who work in particular areas. So GCHQ are kind of interested, Blackso, SmithKline are kind of interested, Unilever are kind of interested, because they're trying to characterize these vast data sets, and they know it's got something to do with the shape of the data set rather than just the individual measurement points that they've been able to sample or make or something like that. So science isn't sleeping, and for a number of years now we've had a huge growth in the world of networks and network theory, so I've been talking a little bit about that to our students this week. But actually this is going to kick on, and there are going to be more and more ideas that come from across a whole range of mathematical sciences. It's maths, statistics, information engineering, computer science, wherever it comes from. And these big ideas, once developed, are going to be applied to whole new areas, not just marketing to customer-facing companies, but actually working across in social sciences, computational social sciences, and so on. So newness, novelty, is always going to be important. And what we want is to develop minds that are going to look at data and just think about it differently, and invent new concepts that we don't know about, new methods that we've never tried, and new ideas that can be put into practices in businesses and make them more competitive and make them kill the opposition. One of the things I do at Oxford is run the Oxford Emirates Data Sciences Lab, and that's about transforming the way Emirates actually manage their business. And there are all sorts of areas there, specific problems they know about, and also problems they haven't even dreamt about, where we can help them with different types of mathematics and statistical sciences. The last part of this is to say something about aspirations. So data science is a lovely thing because it has all the sort of excitement of mathematics that we crave secretly, all of the wonderful things about proving things and learning things and finding a result for the first time and thinking that's great. Problems you can chew over while you're in the pub or in the bath or all of those things. It has all of that. But it also has this possibility now that, you know, it's very much in demand, and so it's possible that quite a lot of science in the next 10 and 20 years, in interfaces between science and other matters, arts and humanities, social sciences, will kind of look like and be driven by data science. So I'd suggest to you that there's certainly academic careers going to be available, and you know, we're hiring a lot of people at the moment, and so is everybody else. So these are great areas if you want an academic career, but they're also great areas if you aspire to run your own company or work in R&D within companies where you really make a big change. One day somebody will say, "Mummy or Daddy, what did you do in the data science revolution? What did you do?" And actually, it may be that you want to say, "Well, one of the things I did was start a company, or I worked with a startup, or I worked inside a company here and changed what the way that worked. And, you know, it was successful on many levels, things like that." So you'll find that the appetite for what is a rare resource, that's talented people thinking outside of the box, prepared to roll their sleeves up, the appetite for that is very, very strong within companies. And actually, about all the reviews of this show that we're in short supply. Now, it's a bit too late for me, but it's never too late for the students at AIMS. So what we want is to everybody to sort of have an aspiration and share a vision that if we've done mathematics, we know stuff about networks, we know stuff about probability, we know stuff about dynamics, we know stuff about inference, we know stuff about modelling, that makes us very natural to work in these kind of areas. So I think the biggest thing is not that there isn't any maths to do. There's lots of wonderful maths to read about and to try out. There are lots of problems, there are lots of companies that are interested, but inside each one of us has to want to roll up our sleeves and make that a choice for our career. And if you do that, I'm sure you'll be rewarded. Thanks very much, everybody.
Questions?
Yeah, sure.
Any discussion or questions? Yeah.
Thank you for your presentation. Is there any indication of a kind of saturation of, let's say, more analysis of the same data and how kind of the usefulness degrades over time?
Oh yeah, that's a great point. Very often when you go to see companies, you say, how much data you got to? Oh, we keep 10 years worth of data. And you sort of say, what's the value of old data? Boy, I never really thought about it. It's very cheap to keep, so we've kept it all, you know. But clearly for the there are two issues there. One is for the modeler. Actually, data does have a sort of shelf life because human behaviour changes. So you need people to think, you know, do people really use our business this year the way they did 3 years ago? No, we've changed it round and we've done that. And that can't be relevant. In terms of the saturation of ideas and things like that, then there are lots of threads moving at different speeds. So sometimes, you know, the whole world of network theory has a big push because there are lots of people working there and there are lots of problems that have begun to be resolved. But then that will get parked and then there'll be something else that comes out of topology or something else that comes out of a different type of theory. Particularly I'm interested in dynamics actually because I think a lot of stuff is done on the principle that everything's in sort of steady state or is static and things like this. If you think about the internet, every time there's an explosion of news it just goes whoosh. I mean there's nothing static or dynamic about that. But I mean, all these threads go at different speeds, and so I don't really see it as saturating. Some of them do feel a bit like sort of dead ends, and then suddenly there's a big surprise. Someone discovers something else, and then we all rush off and do something else. But you know, if you don't try stuff with real data, if you only play about with Mickey Mouse data, you're never really going to make nice discoveries. Because Mickey Mouse data that you have, or you've created for yourself, really only creates the sophistication that you thought about yourself. And I think, you know, the idea of working with real data is always challenging, and there's always a bit of fun in that, because it may not work. What you've planned may not work, and then you learn something. Yes, please.
You mentioned opening data
Yeah.
to researchers or whatever. How does one go about doing that? I mean, obviously you have to anonymize your data, but what more can you say about it?
Okay, so there are a number of ethical problems here, actually, which are quite interesting. So if we're in a university, we decide we're going to do something as an experiment, you know, we're going to have a job advertisement, and everybody's got a dog, we're going to put a dog on the advertisement, everybody's got a cat, we're going to... Actually, you can't really do that in a university, because you have to appeal to the ethics committee, and you say to them, I want to do this, and they say, well, do these people know they're part of a large government? No, they don't, no, they don't do this in cheerio, you can't do this. Right? If a company wants to do this, they just do it. Because they're governed by different forces. They're governed by the terms and conditions with their customers and something called the law. And the biggest force they're governed by is shareholder value. So when they commit a fraud, like Volkswagen did, they can lose possibly half the value of the company, because so many companies are valued on intangibles these days. So there's a real big risk. I don't know of any supermarket that would really stalk its customers on Twitter. We often talk about it, and we always decide not to do it because there's a creepy line, and even though you can do it, you could find your customers and stalk them on Twitter, and then you'd know which football teams they supported, and which comedy shows they liked, and which politicians they disliked, all this sort of thing. Actually, that's a step too far. So, firstly, there's an ethical issue. I think there's also a practical issue in that companies will share data and anonymise data where they can. And we see a lot of companies sharing data on Kaggle competitions. I don't know whether anyone knows the Kaggle website. That's a great resource, I think, because you know you see all sorts of data there. But the problem is that there's some sorts of data that can't really be anonymised and could always be reversed. And I won't give it examples now, but they have to do with people showing particular behaviour, which then makes that we can then back them out, and then we can see where they were last Wednesday and all this sort of thing. So there is a kind of issue there for some companies, but most of the companies, they'll start off carefully and maybe draw you in to come and work in their environment. But I think the trick is to make it very clear that we have to publish papers. That's why we're here. We have to make it clear. This is just a secret where I can give it 10% of my time or 5% of my time, but my real job is to get on with my career. And so that's That's the kind of issue with that. So I think you've got to be really upfront about it, and that's quite difficult for young early career, let's say for early career scientists. It's quite difficult because you don't always have the confidence to sort of push back on that. But you've got to try and kind of make that line one of the this is what we're looking for. And actually that does mean that we are looking to publish things, and we will have to work on that problem. And if companies like you enough, they'll resolve that problem with you. But usually you've got to go through a period where you build some trust. Okay. Yes, please.
You mentioned the ethics. I imagine there are many lines. How close to those lines do you walk? How strong does industry push to cross those?
Confusion and distress arises when people try to jump from one sphere to another. So there was an instance where Facebook tried to publish as if they were a company, and they got a PNAS paper, and then, and they hadn't been through any of the normal things that academics would have been through. Actually, the mistake there was to try and present themselves as if this was analytics code. I think there are three spheres. I've written about this, and they've each got different governing forces. There's academic research, which has governing forces. We have ethics committees, we have responsible research and innovation programs, and things like that. And that's to stop scientists doing Frankenstein things. We were well-meaning, but we did something mad. That's what that's there for. We've suddenly got a program where, the Daily Mail, which is a right-wing, fairly reactionary newspaper in the UK, would sort of say, all scientists from the University of Oxford are stalking children. And you think, oh, how the hell did that happen? Oh, I suppose we are stalking children. Oh, yes. This is very sick. So that academic sphere is one. The corporate sphere is governed by different forces, and they occasionally collide. But the mistake is they collide when we're doing stuff online, and we think of it all as one marketplace, an internet where everything's going on, and it's not the same at all. These people have contractual relationships. We can argue about the ethics of having tick box. I've read the terms and conditions, and I agree with them. I mean, that seems a little bit unethical to me, but nevertheless there's an implied consent, and they do rest on that. The third sphere, which we haven't talked about at all, is the public sector, the government, security services and things like that, where these guys are obsessed with joining data up. And they're obsessed with that because they believe it drives efficiencies. And it maybe does or maybe doesn't, but it's kind of everywhere you go, there'll be big programs to, take social security data and put it to the police and criminal data, or put it onto health data from the health sorts of funds. Sometimes that's helpful. When you want to tax your car in the UK, you don't need your MOT certificate anymore. It knows whether you've got one. Sometimes it's helpful. And very often it's unhelpful, expensive, and fails. Quite why this is sold as a thing that would actually save money is actually the wrong way around. They should think of their data science programs in public sector as things that will create new opportunities. Instead, what they try and do, they try and write the old operations in the new world of digital data science. And they should be thinking, well, what can we do that we never did before, which is a game changer. And of course, they don't have that mindset, a much more defensive mindset. And also, they've got certain suppliers that supply into government and public sector, which only sell what's on the van. They're not going to rethink that. They just want, IBM, they're only going to sell what's on the van. Right, so there's no agility there, no creativity with something what's on the van. Right, so those three spheres are very, very separate, and they have very, very different ethical conditions on them. And as we move from one to the other, we must be very, very aware of which sphere we're sitting in.
I think we better move on. Thank you.
Okay, well, thanks very much, everybody.
We'll have a couple of minutes while Jacques sets up.
Great, thanks. Thanks, Jim. Good.
Thanks. Thanks very much.
So, Jim, you've got the agenda.
Yeah. So, just introduce you. Next, it's a pleasure to introduce Dr. Jacques Ludik, MIIA, and Cortex Logic. He'll take it from here, but I just want to repeat that it's due to him and me, together with Bubakar, where he is here. So thank you, and a pleasure to introduce Jacques.
Thank you, Jeff. Much appreciated. Let me just get the connection going here. So, Jeff has agreed to, I'll introduce, he's introduced me, and Pete and I'll introduce the rest of the speakers as well. So I know, first of all, who is at MIIA? Who knows, who's MIIA members here? Great. So a lot of people that can join MIIA. MIIA is the Machine Intelligence Institute of Africa. I know there's a lot of students here as well. So you're most welcome to join there. You go to machineintelligenceafrica.org. It's a non-profit. It's really about how do we use data science, machine intelligence, AI to help transform Africa in terms of research applications and so forth. So in terms of Pete, where's Pete now? Is it the back? Anyway, so I'm actually going to add on to what he was saying. So I built the whole career on pretty much AI, artificial intelligence, and its applications. So I'll share a bit of that, given that there's a lot of students here. So really looking forward to that. But let me quickly set up and get going. What we also do on the Machine Intelligence Institute of Africa website, we try to share. So, and we are not only based here in South Africa, we're trying to involve the whole African community. Now I know that AIMS is, you've got, sorry for that, let's put this in, let's get this in the right resolution here. Some differences. What I'll put it in. Should work full screen mode. Yep. Okay, so what you will find on the MIIA website, we share our presentations, the videos. We're actually recording stuff here so we can share it with the rest of the community. There's about 1,550 plus people that's on this joined via social channels that's participating. But we're also helping Data Science Nigeria. So we've been participating and helping them with their boot camps as well. And the interest for us is to really network together critical resources around data science and AI, everybody that's interested in this area, and then make a difference, solve problems. So we also interacted with the World Bank, the Gates Foundation, and other organizations, PwC, Deloitte, IBM sponsored hackathons as well. So we want to engage the community. There's lots of stakeholders. We are quite happy to work with AIMS. I always wanted to do something with AIMS, and I met Bubakar at a MIIA meetup last year. We talked about, earlier this year, and we also met at a deep learning in Indaba. By the way, who was there at the deep learning in Indaba? 1, 2, 3. I was there 4. Okay, it was a lot. There were 300 data deep learning practitioners. People, and it was quite fascinating to just be there and experience other people, just interact with them, and talking about data science, AI, machine learning. And what was really cool to see ex-South African, well, still South Africans, but people that's working at Google Brain or working at DeepMind, participating and want to share. So, and this is exactly the spirit of MIIA as well. So, as we have limited time, we've got pretty much 20-25 minutes allotted to each speaker, and there's going to be questions and answers as well. I'll try to keep it short, but I just want to refer you back to the website. If you go to the events channel, you can also join Slack. There's a Slack channel as well. We share all of these kind of stuff. This is a presentation that I've presented at the AI Africa conference in Johannesburg, and they asked me specifically to talk about AI in Africa, the past, present, and future. And as this is still a fairly new field. I talked about the past, present, and future, and obviously mentioned all the exciting stuff that's happening. And we've got some speakers from Zoona here as well. They're doing some great stuff as well. Obviously, my first AI company that I sold to General Electric was probably one of the first AI companies in the country, or Africa even, because it's still a new field. And we applied AI to a large range of different problems across multiple industries and sold the software internationally. And then I sold that company, General Electric, as well. So that's probably the first African company sold to a multinational. So that's possible. Just for all the students here, Pete talked about what you can do with the field potential. It's amazing. We've got PhD astrophysicists, I've appointed PhD physicists, and there's people from actuarial background, all sorts of different backgrounds with good data analysis skills that can make a contribution. And there's so much to unlock. The major tech players are all vying for the AI throne. So data is the new oil. So there is really tremendous opportunities. And I'll share a little bit of what we're doing right now as well. So I'm not going to, maybe just very brief, I just want to touch on a few slides. My personal massive transformative purpose is around this, shaping a better future in the smart technology era. And when we talk about smart technology era, it's like the fourth industrial revolution. Who heard about that? Fourth industrial revolution. Yep, it's a few people. At GE, we talked about industrial internet. In Germany, we talked about industry 4.0. And it's really the fusion of all these exponential technologies that's really shaping and changing everything. You're seeing devices becoming intelligent. You're seeing a lot more value unlocked from data. But you also see a fusion of different types of smart technologies as well. You see it with biotech, and you see it with all these kind of things. And I've got this particular presentation is actually giving a history of all the industrial revolutions, and also talking about what people are saying about it. So, and I'm just going to quickly reference this, and I'm going to dig into practical things that I'm doing right now as well in terms of this. So. This is just a little bit of history. I'm not going to go into details too much, but as I mentioned, did my PhD in AI recurrent neural nets at Stellenbosch University, and then did a bit of research, initially applying AI, but then went straight into applications of AI, and then into business, and C-Sense was that first business that I sold to GE, and incredible experience, just to talk to customers and looking at their problems and trying to address that. And operationalizing data science. Well, that's what it's about. Not just doing an offline consultation here, but trying to operationalize it. But the rest of it, I'm not going to go into too much detail there. So what I want to also just briefly mention, this is just some of the things. This is MIIA, so Machine Intelligence Institute of Africa. It's another name for artificial intelligence. And I'll talk more about, if you go to the website, you will see what we aim to do, what are the problems. We've looked at the African problems and what we potentially can do here as well. This is just showing the growth. Okay, so just from a fourth industrial revolution perspective, this is what some people are saying. So Professor Klaus Schwab, he was saying in the new world, it's not the big fish that eats the small fish, it's this fast fish that's eating the slow fish. And it's really like that. We live in an age of networks, of platform businesses, and Peter was talking about that. But you truly see a compression of time. So it's about a quick move. You need to execute very quickly. You can't just be slow in terms of what you do. So because things are moving much quicker. But we also see an exponential growth in data, structured, unstructured IoT data as well. And as Cortex Logic, my AI company right now, what we are doing is we also partnering with the IoT providers as well, and make sure we collaborate with all the different players to make sure we can access all the relevant data as part of an end-to-end solution. And I'll talk more about that as well. But it's really a new era with tremendous opportunities, and I'll refer to a little bit about. I'll mention some of the things that's happening as well. But this is just what some people are saying. There never has been a time of great promise and peril, or great peril. It's there to utilize. So, and also velocity, scope, and systems impact is tremendous. It affects all industries. There's not an industry that's untouched by this. Okay, so and this is kind of the exponential curve. We can see speed of technology change in the smart technology era. You see all these kind of technologies, biotech, neurotech. We've got one speaker that's going to talk about Chris Currin done from a neuroscience perspective as well. It's going to be quite interesting as well. But you see the convergence of these kind of things and all coming together, and we can unlock tremendous value. All right, so I'm going to just get out of this one because I want to get to this particular one. It's kind of my latest presentation. Okay, this is just a bit of a slant on IoT, Internet of Things, but what we do is really to provide an AI engine to help businesses thrive in the smart technology era. So that's exactly. So what does it mean? It means to operationalize big data analytics. How do you take this exponential growth in structured, unstructured IoT data and make sense out of that and create end-to-end solutions that are actually making a difference for the businesses, increasing the throughput, the yield, reducing risks, all of those type of things. So when we engage, we actually engage with the C-level or the executives in the companies that understand their bottom line. And then you say, okay, how do we, from there, create this end-to-end solution? So you start there, you start with those business cases. For De Beers, for instance, we've got a project going on and we're evaluating the whole business, looking at all the business case, and then we can set up very specific solutions to address that. And it's like that for all types of companies. And I see actually AI right now, there's multiple applications, but it's clearly to unlock value from structured, unstructured IoT type of data. But it's also on the human-computer interface side, because if you look at the deep learning or the AI toolbox right now, it has been enriched tremendously in the last few years with especially deep learning, but other techniques as well. And you can utilize those techniques to create valuable solutions on the human-computer interface side as well. It's creating intelligent virtual assistants and all sorts of things on that level. So this is effectively really what it's about. You can't operationalize AI if you haven't sorted out your big data analytics infrastructure, especially if you want to address huge cases. So you want to enable your big data for automated AI. You also want to move to a situation where it's not just offline, but real-time online solutions that's actually continuously being updated and stay in touch. Because if you want to move quickly, you want to make sure it's automated. And you also want to make sure it's properly integrated into the business. It needs to be integrated into the omni-channels. It needs to be personalized real-time offers. If it's in industrial space, it's going to be in systems that's fully integrated into your SCADA systems, your PLC systems that actually does the closed-loop control, for instance, or identify real-time causes of any particular instrument. Or equipment. If the equipment is failing, it's not working, then you've got a problem. And you want to prevent that. So there's a big use case around preventative maintenance. And one of the big reasons why GE acquired C-Sense as well was really around what is the use case around predictive maintenance. GE's got billions of dollars, hundreds of billions of dollars of service level agreements around these kind of things as well, predictive maintenance. Okay, so this is just around that. So I'll skip some of the slides here. But just to show you a little bit of the opportunities and how things evolve, and just maybe, so what's happening right now? Some of the companies that really struggle to unlock the value, they don't know, they get stuck. And we're engaging with multiple companies where there's IT is doing something, data science is doing something, but they can't get the things operationalized. So what we are doing now is to say, okay, we'll form joint ventures, or we'll come to you and we'll provide end-to-end solutions for you, and maybe we take upside. So we're changing the business models as well. So that's how we're helping corporates, because corporates, we talk about the fast fish, the slow fish. So a lot of these corporates are moving slow, and they need to change their game, because you've got a lot of platform businesses that's coming to the front and is agile and move quickly. And it's actually potentially as well as disruptors in the market. You see with Airbnb, Uber, all these kind of companies. And I've got a list of companies here that's really coming and coming with new business models, platform types of businesses, and they all need AI engines to operationalize it. And this is then what we do there. But then with corporates, we help them compete as well. And what's quite interesting, maybe you want to work at PwC, Deloitte, all those kind of companies. We've got joint business relationships with them because they are also being disrupted and they realize they can't be just an auditing. They need to be looking at solutions and they need to operationalize data science and AI. So we're helping them to actually do that. So for instance, in cybersecurity, we are building solutions around cybersecurity using AI data science for them that they can roll out through their channels as well. So from a business perspective, we recognize the new era, smart technology era, where there's a lot of platform businesses and networks. And if you want to scale, you want to actually look at opportunities where you can do that properly. And some of these companies are market-leading companies, and they've got there's a lot of opportunities there. And if you help them reshape that, there's huge opportunities to unlock value and make a difference. So, and then you can't do it alone. So if you want to move quickly, I've got slides that talks about where Accenture is talking about innovation on the y-axis, collaboration on the x-axis, and they've looked at companies where they can classify them there. Most companies are observers, not really doing a lot of innovation and collaborating. But the ones that are moving the fastest is the ones that's doing collaboration and invention. It sits there in the top quadrant. And if you want to move quickly, we talked about speed, plug and play. We live in an API economy, it's just plug and play stuff. It's even like that on the business level and partnership level as well. So we are partnered with, we've got a bunch of technology solution partners where we just help us to move very quickly. So Sigfox, I don't know if you have heard about Sigfox, but Sigfox is an example of an IoT company that provides connectivity and for all sorts of, you can go to the website and read more about that, but they're a massive enabler for IoT in South Africa and Africa in general. They're quite big in Europe as well, but there's companies like that, for instance. But there's a bunch of others. The Googles with TensorFlow and all their APIs. If you think about cloud, you need cloud computing now. You want to do things quickly. So you've got Microsoft Azure, which is good. You've got Amazon, which is excellent as well, probably the two leading ones right now. But there's a whole ecosystem of technology that you can utilize as well. So we're partnering with them as part of providing end-to-end solutions as well. And that's how you need to think about it. You can't just, and also talent, people. So that's why I founded Machine Intelligence in South Africa, is just to, and it's not just for us, it's for everyone that want to utilize that. And it's just a community of people interested in this area. People like you, and passionate about solving problems and making a difference using this type of technologies. There's a world that waits to solve problems, and maybe I'll end with this because we're running late as well. So if you look at the example value drivers for business and corporates, it's really summarized for multiple industries in this slide here. So you can see the stuff that I've talked about: productivity, revenue, reducing risk, lowering costs. You can really look at anything. If you think about customer churn, that's you want models around that. You want to reduce the risk. There's fraud, waste, and abuse. You want to handle that in real time. Cybersecurity, that's a risk business case. But it's not only about increasing operational efficiency, it's also about that enhanced customer experience. And this is what you can get with data science, because you can provide that real-time, personalized offers at the right time. There's so much more that we can do on that front as well. Okay, there's a lot more to go through, but I think I'll stop here. There's some really fascinating stuff. This could be another few presentations. So, is there any questions at this point? Anything? Go. Yep.
Are we aware that the existing machine learning algorithm doing extracting or unlocking information from the structured and unstructured data?
Okay, I want to make sure I understand it. I heard, you maybe can speak up a little bit. Structured, unstructured, how are you unlocking value from structured, unstructured data? Okay, so if you look at unstructured data, it's typically text, video, audio. It's unstructured could be, if you look at text, you want to do sentiment analysis, or you want to really figure out how people, so you want to analyze all of that. How do you do that typically? And the big thing is, You want to create a middle layer on top of that because you want to bring all your structured data. The structured data is maybe your demographic information, it's the product information, everything around that you've got. Say what banks, if you look at the banking environment, they've got all your banking information, credit cards, all that information, demographic information. But then when you add social media, they can look at, say, your Twitter account, whatever, they can look at sentiment, things you're interested in as well. You can bring that. So you need to merge those data sets as well. If there's other types of things like IoT, maybe wearables, health information around you can bring that into the mix. If there's any behavioral or any other things that they pick up, you can bring that into the mix. So there's many use cases around this. And actually in this slide deck, I haven't got to that, that's maybe the interesting part, is you actually go to all the various use cases. Now we've got it for retail, for healthcare, you can look at all the various ones, and it's amazing the potential and possibilities, especially if you've got people instrumented. And that makes a difference in the industrial world, to have around a piece of equipment, let's say a drill or anything, you've got temperature sensors, say pressure sensors, flow sensors, all sorts of different things. That gives you a lot of information around this piece of equipment and around the process. Around humans, obviously with social media, with our smartphones and stuff, we're giving a lot of companies a lot of information about ourselves. If you are, I just read about, a guy told me about this pill that's been approved by the FDA that you can swallow, and it's fine, everything, and that gives a lot of information. So every time you use the pill, it gives you a bunch of information about your health. There's going to be a lot more information like that, and there's obviously the wearables and stuff like that. So all of that you can work with, and you can create applications that maybe even with visual stuff can look at you and see all sorts of different things and react to you in a natural way. I don't know if that helped. Yes.
Are we using machine learning algorithms to extract insight from this data, or there are some in-house algorithms that companies are using to tap into this data?
Okay, I need to understand this.
Are we using machine learning algorithms to extract insight from these structured data? Are we using that? Or companies are in-house algorithms that is doing the job?
Yeah, so basically, a lot of companies, if you look at Zoona, you're going to talk about customized value. You're going to talk about when you're using machine learning in-house. They've got data scientists like we do as well. So we enable other companies to unlock value. But you've got companies, a lot of companies, even at Juma where I was at General Electric, we were using machine learning to unlock the value. So at GE, it was all about predictive maintenance and process optimization. At Zoona, you're going to talk about customer lifetime value. It's all about the customer, personalized real-time offers, providing the right offer to the right person. They've got a whole team doing that. So yeah. Okay, I think we are probably out of time, so let's move on to the next. Okay, so next is Dr. Sebnem. She's from Statistical Science Department, University of Cape Town, and she's going to talk about an interesting topic, reproducible research. So looking forward to that. Sebnem, nice to meet you as well. So yeah, you can. You want to use this? Okay, that's perfect. So let's do it. Okay. Thuso, do you have a computer here?
No, I don't.
No, I just want to, Chris?
Yeah.
You've got a computer here.
Yeah.
I just want to make sure because we can, I've got Thuso's presentation that we don't reading this thing.
It's quite short. Useful. Because the slides are available, you can have a look at it. As Jacques said, my name is Sebnem. I'm coming from the University of Cape Town, the Statistical Sciences Department. I'm originally Turkish. I just want to talk about a few experiences of mine throughout my research. I know you all are doing some sort of research. You're publishing, you're going to conferences.